All right, we are live. Welcome on in, everyone. Robert, the AP Math guy, and tonight we're going to be talking. We're going to be talking about position, velocity, and acceleration. Welcome, welcome on in. As people are going to join, as people join in, I'm going to go ahead and wave at you if I'm able to by pressing the button, and if not, I will go ahead and wave now. Hi, everyone. Thank you, Frog, for for liking the live. So I'm gonna go ahead. I don't have so I ran out of glue in my glue stick. So tonight I'm just using the regular glue if it will cooperate. Hey, Jimena, how's it going? You asked me for it. Are you talking about this topic? Because that is exactly what we are doing tonight. But I'm hoping that my glue will cooperate. Otherwise, I may need to go get some tape, or I may have to write these problems down. Which, if it comes down to it, I don't mind doing. Please don't tell me to. That would explain why. That would explain why my I can't glue it. There we go. That should fix the problem. Now I should be able to use the glue. There we go. All right. Welcome, welcome on in, everyone. Thank you all for the mad taps as we begin this live. Hopefully everyone's had a great Saturday. Go. Again, I'm going to spend the next couple minutes just saying hi to everyone. Thank you for the mad taps. And for those of you who I can't physically press a button to wave to, I can always physically wave to you. All right, all right. So, we have spent the last 3 days or so on related rates. Hey, Brandsy, how's it going? How is it going tonight? So, anyway, so we spent the last few nights talking about related rates. Going good studying Calc 3? All right, that's cool. That is really cool. So tonight we're gonna move on from that because I think 3 nights of related rates is maybe it's not enough, but um I'm gonna move on to different types of problems. So hey sir, how's it going? Welcome, Platt. Take the second derivative, which I'm too lazy to do. Yeah, we're gonna end up taking the second derivative, but we're going to we're just waiting to get started. Calc 2 is harder. I agree. I fully agree that Calc 2 is harder than Calculus 1, and I even think it's a little more difficult than Calc 3. But yeah, so we have people joining on in, but let's go ahead and get started. So we are going to be talking about position, velocity, and acceleration. Now, how are these three things related? So I'm just going to write quickly here. Position, we're going to write as x of t. So this is our position function. And you'll see me denote it as x of t unless it's otherwise given. And then v of t is our velocity function, or at least that's what I'm going to denote it as this evening. And then, hey J-Up, how's it going? Integrate the position of equation derivative, I mean. Exactly, so we're going to get there in just a moment. And then, acceleration, which I'll denote as a of t for tonight. So, velocity, v of t, is going to equal first derivative of position, and acceleration is going to be the first derivative of velocity, which is the second derivative of position. Today's kids will just ask GPT. Maybe, but I've seen GPT get questions like this wrong before. So the thing is, here's my warning to anyone that wants to use ChatGPT for, or any form of AI for math problems. Be careful. Why? Because I've seen several times where I plug in a question to ChatGPT and it gets the question completely wrong. Thank you, Blend, for the follow. So if you're going to use ChatGPT, just be careful. Trust ChatGPT doesn't do good in college level physics. Yeah, ChatGPT is bad for math. It's more conceptual. Yeah. So, and that's the thing. Do I think that that AI is something that I would say never use it? No, don't you ever use it. No, no, no. No, of course not. It's technology that's going to be important. But I'm saying, just like with calculators, don't rely on it. So, let's go ahead and get started with our first problem of the evening. So I'm going to go ahead and zoom in a little bit. Apparently, this glue isn't doing such a good job, but that's okay. We'll make it work. The position equation for the movement of a particle is given by S equals t, the quantity t squared minus 1 all cubed, where S is measured in feet and t is measured in seconds. Find the acceleration at time equals 2 seconds. I mean, AI could help you do it step by step, but it's not 100% correct all the time. Absolutely, I agree. Thank you, Adriana, for the follow. So, let's go ahead and find the acceleration. So here, I see that a of t is my acceleration, and a of t is the first derivative of velocity. Let's go. Good job, Robert. So it's the first derivative of velocity, which means it's the second derivative of position. And we're given the position function. What is the position function? The position function is S is equal to the quantity t squared minus 1 all cubed. So let's write that down. So we know we know that s is equal to t squared minus 1 all cubed. And we want to know, a of 2. So here, I'm going to go ahead and take the first derivative to find my velocity. Why? Because in order to find acceleration, I need to find velocity first, because I can't find the acceleration without first finding the velocity function. So let's find the first derivative of x. So v of t is equal to, well, what rule am I going to have to use for this first problem? Yes, Brandsy, that's exactly right. Chain rule. Is this for the ASVAB? Nope. You will not. As far as I know, you will not see calculus at all on the ASVAB. So, let me get my water bottle. So remember what chain rule says. Chain rule says that if I have a function trapped within another function, I first take the derivative of the outer function, leaving the inside alone, and then I multiply it by the derivative of the inside. So, now, let's go ahead and take the derivative of this. So my inner function is t squared minus 1, and my outer function is this cubed. So instead of finding the derivative of t squared minus 1 all cubed, let's find the derivative of bottle cap cubed. Thank you, Claude, for the follow. Do you also go over energy problems, law of conservation of energy, stuff like that? It has been a long time since I've done physics. I'm sure if I studied up, I could, but I'd have to review it myself first. And thank you, Chris, for sharing the live. So, yes, bottle cap. Yes, KG. So, what is the derivative of bottle cap cubed? Right, Brandsy, it's going to be 3 times the bottle cap squared. And how do I know that? Well, we use power rule. And what does power rule say? Power rule says if I have x raised to a power, its derivative, I can move the exponent out front and multiply by whatever coefficients in front of a variable, and then subtract 1 from the exponent. So, I have 3 times whatever was underneath my bottle cap squared. What was underneath the bottle cap? It was t squared minus 1. T squared minus 1. And then I need to multiply by the derivative of this inside part. So, would you be able to post videos of physics concepts like kinematic equations, projectile motion examples? Again, it's been a while since I've done actual physics that hasn't had anything to do with calculus, but I'm sure I could, but I'd have to relearn some stuff. So anyway, here, I need to take the derivative of t squared minus 1. Well, again, I can use power rule for this one. So the derivative of t squared, move the 2 out front, and subtract 1 from the exponent. So I have 2t to the 2 minus 1, which is 1. That's right, Brandsy. And then remember, a variable without an exponent is the same as that variable raised to the first power. Is this calc-based physics? It's an application of that, but this is Calculus 1. And then, what is the derivative of negative 1? That's right. So, remember that if I have f of x is equal to a constant, its derivative is going to equal 0. So this is going to be 2t minus 0. So that is going to be 2t. can you go over Taylor series? I actually have that on my list of topics that I am going to be going that have been requested. It's gonna be a little bit before I go over Taylor series, but I do plan on going over Taylor series eventually. I'm thinking, and again, this is just a estimate. I don't exactly have my plans in front of me right now. If I had to guess, I'm thinking I'm gonna be going over Taylor series probably sometime in November. But again, I don't have my plans in front of me. It could be sooner, but that's where I think it is right now. If I had to guess, so what I'm going to do here, because I want to simplify this before I continue, I'm going to go ahead and multiply 3 and 2t. So let me zoom out a little bit so that way we can see a little bit more of the problem. And let me focus. There we go. So this is going to be 6t times t squared minus 1 all squared. Thank you, Joseph, for the follow, and thank you, Mark, for the follow. So now, let's find the function for acceleration. So remember, acceleration is the first derivative of velocity. Thank you, Mark, for the tiny, tiny hot dog. I think that's what it's called. Thank you for 2 of them. Or actually, I should say, thank you for the 2 tiny dinies and the 2... Did you... Okay, I'm... Alright, so thank you for the 2 tiny dinies, the 2 tiny dinies in love, and the 1 tiny diny hot dog. So anyway, here, I now need to employ 2 different rules to continue. What 2 rules am I going to use to find the derivative of velocity? That's right, Frog. I'm going to use product rule because I have a function times another function, and I'm also going to use chain rule because I have a function trapped inside a different function. So let's go ahead and mark our functions. So remember the product rule. The product rule says that if I have a function times another function, the derivative is equal to the derivative of the first function times the second. And then we switch the dance partners around by taking the derivative of the second function times the first function. And we add those 2 products together. So, how do you derive natural log? I know that natural log is usually 1 over x, but is there more info to this? So, the derivative, you're right, the derivative of natural log of x is 1 over x, but if there's something inside the natural log, the derivative is going to be the derivative of the inside over the inside. Is this calculus? It is indeed. Thank you, SVT, for the follow. So, here, excuse me. So I'm going to let g of x, or g of t equals 6t, and then h of t be t squared minus 1 all squared. So if g of t is equal to 6t, what would g prime of t be? Right, Frog, it's going to be 6. That's right, Shamrock, and right, William, that would indeed be 6. Now, I want to find the derivative of t squared minus 1 all squared. So instead of doing that, let's find the derivative of bottle cap squared. What's the derivative of bottle cap squared? Shamrock says 2 bottle cap. Ormsy says 1. Are you able to go over cylindrical disc and shells? I am, but I'm going to be covering that later on. Um, Thank you, Sack Stop, for the follow. But yeah, so I do plan on going over Calc 2. I plan on going over Calc 2 probably sometime in. I plan on starting that around early October. I don't think I have too much of Calc 1 left to go. Yeah, no problem. Thank you, Green, for the follow. Green Dejani. Thank you for the follow. Alright, so the derivative of bottle cap squared, well, it's going to be take my exponent, move it out front, and subtract 1 from the exponent. So it's going to be whatever's underneath my bottle cap, raise, or actually, times 2. And what's underneath the bottle cap? It's going to be t squared minus 1. Thank you, Ryan, for the follow. Just followed you, boss. How often do you go live to teach? I go live every night at 11:30 p.m. Eastern. Is this one-dimensional kinematic equation motion? I'm not sure. We're happy to have you. And then, just like before, I need to take the derivative of the inside part, which we already found to be 2t. So if I want to simplify this, it's going to be 2 times 2t is 4t times t squared minus 1. I do have chain rule here. So now I have everything I need to find my derivative. Use the product rule. So I'm going to link these two functions together, and I'm going to link these two functions together. So now, remember the product rule. Product rule says derivative of first times second, so that's going to be 6 times t squared minus 1 all squared, t squared minus 1 all squared, plus the derivative of the second times the first. So I have 6t times 4t times t squared minus 1. 6t times 4t gives me 24t squared. And that's going to be multiplied by t squared minus 1. So normally what I could do is I could simplify this by foiling this binomial twice, distributing the 6, and then distributing in that 24t squared into this set of parentheses. But instead, I'm going to go ahead and just plug in 2 for t. So when I plug in 2 here, it's going to go everywhere I see a t. So it's going to go 2 is going to go here, 2 is going to go there, and 2 is going to go there. So a of 2 is going to equal 6 times 2 squared minus 1 all squared plus 24 times 2 squared times 2 squared minus 1. And I'm running out of space here, so I'm going to go ahead and move down a little bit. I'm going to draw my arrow down here. So I have a of 2 is equal 2 squared minus 1 is 3. So I have 6 times 3 squared plus 2 squared is 4. 24 times 4, I believe that gives me 96. Times 3. I believe that's right. 48. 24 times 4 is the same as 48 times 2, which is 96. Yes. Okay, so if this is the case, then what must a of 2 equal? So what must a of 2 be? Can you zoom it out a bit? Sure. I can't zoom much more, but I can zoom out a little bit more. Is that good? Thank you, Fuego, for the follow. Yeah, no problem. No problem at all. Is this Calc 1? It is indeed. It is indeed Calculus 1. Right, David, it's going to be 342. Why? 3 squared is 9. 9 times 6 is 54. 96 times 3, I get 288. And so the acceleration at 2 seconds is equal to 342. But because we're talking about acceleration, I need to find my unit. So remember, my position was measured in feet and my time is in seconds. So my unit is going to be 342 feet per second. But remember, since I'm taking acceleration, I need to square my time unit. So my acceleration is always in distance over time squared. Thank you, I Love Football, for the follow. Have an exam on that next week. Awesome. How do you feel about it on a scale of 1 to 10? Seven? Okay. Okay. Hopefully we help you get to a 10 or at least an 8. Thank you, Vinny, for the follow. I have an exam on this next week too. Been trying to study. I assume you meant study chapter 2 all weekend. Okay. So I'll ask you the same question I asked I Love Football. On a scale of 1 to 10, how do you feel about this exam coming up? That's okay. 6 right now. Okay. That's fair. Hopefully after tonight we can get you to as close to a 10 as possible, or at the very least more than a 6. How hard is Unit 4 of AP Calc AB compared to the ones previous to it? So Unit 4 is going to deal a lot with applications of derivatives. So you're going to see stuff like related rates, critical points. You might see, yeah, I would agree. It's one of the hardest units in Calc AB. But on a scale of 1 to 10, IA, how do you feel about your derivative knowledge? $8.8. That's good. That's really good. Then a lot of related rates is just knowing what formulas you're going to use. After that, the calculus falls into place. Currently failing pre-calc IMG. I don't believe that. I don't believe that you're dumb. I don't believe that at all. Please don't. I think you're struggling right now with pre-calc, but it doesn't mean that you're dumb. The fact that you're taking pre-calc at all means that you're not dumb at all. Absolutely. It's gonna you've only just begun. I forget which football coach said it or not, but there was a coach that said it doesn't matter how you start, it's how you finish. And you know what? You're right now is just a hard time, but I know you're gonna rebound. Would you be able to do a question on factoring trinomials? Actually, I wonder. I may have one of those here. If not, I can definitely add it to the list. So, let me just take a look and see if I'm going to run into a problem like that tonight. Don't see any, but yeah, I'll add it to my list. Oh, by the way, I finally decided that I'm running out of space on my note card, so I'm transferring everything from this note card and this note card to a list in a notebook. So that way, as soon as I'm done, I can just cross stuff off. But yeah, I can definitely add that to the list. So, hey EJ, how's it going? So factoring trinomials. All right, so it is now on the list. What would you say is the hardest Calc 3 unit? For me personally, it was partial derivatives. I thought were pretty easy. I would probably say it was directional derivatives. Do eigenvectors. Another thing I can add to the list. So I assume you want eigenvalues as well. So gradients, I think so, but I have to take a look at it. Integration by parts, yes. For me, integration by parts wasn't horrible. It was difficult, but it wasn't the hardest thing. So Calc 2 for me was dealing with cylinders and shells. That for me was the hardest part of that class. So yeah. Any questions so far? Oh wow, we're already almost 35 minutes into this live. All right. Can you do delta epsilon definition of limit to prove continuity? It is actually funny that you mentioned that. So, I uploaded a few. I'm in the process of downloading all my lives, and I've done a live on delta epsilon already. But I think tonight or tomorrow, if you go here and you go here, you'll be able to find that live. I'm going to be uploading more of them tonight and tomorrow. Well, later today because it's now Sunday morning here on the East Coast. So, let's go ahead and move on to question number 2. So, hopefully the glue cooperates this time. Oh, did I shut it? I did. There we go. Here we go. All right. Suppose the position equation for a moving object is given by S of t is equal to 3t squared plus 2t plus 5, where S is measured in meters and t is measured in seconds. Find the velocity of the object when t equals 2. All right, so for this one, we're going to go ahead and find, our want is velocity at 2. So we know S of t is equal to 3t squared plus 2t plus 5. And our want v of 2. That's right, Phil. So velocity is the first derivative of position. And since we're given our position function, we want to find our velocity function. So I need to take the first derivative of this function. Nope, I want to start with t. Then we'll plug in. So what is the derivative of this function? What will my velocity function be? All right, Phil says 6t plus 2. Do we have any agreement? Yeah. Brayman says 14. I think you're a little ahead of me, Brayman. David says yes. Awesome. Yeah, I agree as well. So the derivative of 3t squared, remember, using power rule, I take my 2, move it out front, and multiply it by this 3, so I get 6. T to the 2 minus 1 is 1. Thank you, Sama, for the follow. And remember that a variable without an exponent is the same as that variable raised to the first power. And then, remembering that rule, I can say that this is 2t to the first. So I'm going to take my 1, move it out front, and I get 2 times t to the 1 minus 1, which is 0. And remember that anything other than 0 raised to the 0 is not 0, it's 1. So 2 times 1 is 2. Right, so now that we've found our velocity, I'm going to go ahead and plug in 2 for t. So I have v of 2 is equal to 6 times 2 plus 2. If that's the case, then what's my answer going to be? Power says 14, and Brainman, I agree with you. You say 14 as well. So yeah, the answer, right, David, is going to be 14. And remember our units. So my unit, this was measured in meters, and time is measured in seconds. So this is going to be meters per second. And that is it. Is this Calc 3? Nope, this is Calc 1. This is Calc 1. So before I continue, I'm going to go ahead and talk about velocity and acceleration. So when we talk, or position as well. So when we talk about position, our units are going to be in measurement, or are going to be in measurement. So like meters, or feet, or inches, or centimeters, or anything that relates to that. And then velocity is going to be units of measure over units of time. So it would be like meters per second, or feet per second, or mile per hour, or anything like that. Velocity is first derivative, right? And acceleration is second derivative? Correct. That is correct. And then acceleration is like velocity, except my time unit is going to be squared. So this would be stuff like feet per second squared, or meters per second squared, or mile per hour squared, dot, dot, dot. So that's a very important thing to remember, because I've seen students lose points because they didn't include the correct unit. Thank you, Jules, for the follow. I know PEMDAS works for this, but does it work every time when you do the exponent times the coefficient? Thank you, Precious, for the follow. I'm going to read that question one more time. I know PEMDAS works for this, but does it work every time when you do the exponent times the coefficient? So, are you talking about like when I went from here to here? Thank you, Tara, for the follow. Okay, so this is called what we were doing here is called taking the derivative, and the derivative tells the story of the slope. So it essentially tells us what the slope of the tangent line is at a point. So when I did that, when I multiplied my coefficient times my exponent, I essentially did what was called power rule. And power rule says that if I take my exponent, move it out front, and subtract 1 from the exponent. Explain acceleration squared. So are you talking about like here where my time unit is squared? Okay. So, when we talk about movement, so velocity tells us how fast we're going, right? Like if I'm driving 60 miles an hour in some direction, well actually there's a difference between, so okay, quick thing on velocity versus speed. Speed is known as a scalar quantity. So it doesn't matter which direction you're going, your speed is always going to be positive. Velocity, on the other hand, can be negative because it's what we call a vector quantity. So it takes into account both magnitude and direction. So when we talk about velocity, if we see that we have a negative velocity, it means that we're going in an opposite direction. Acceleration is how fast is my velocity going. So think of it like when I'm driving a car, if this velocity that I'm going is increasing, then then I'm accelerating, right? If I go faster now than I did 5 seconds ago, that means I've accelerated. Whereas if I go slower, I'm decelerating, right? Or so the reason why it's my time unit is being squared is because if my velocity is single exponent with time, and my acceleration tells me how fast my velocity is changing, so that's why it's second squared. I'm sure there's a better physics explanation to that. But as I said, it's been a while since I've taken physics. Hey, old boomer teacher, thank you for the follow. Yeah, no problem. I hope that answers your question. Thank you, Damaged, for the follow, and thank you, User, for the follow. So cool. Let's go ahead and try another one. So now we're going to move away from, actually, all right, so the next few questions are going to be a little different. So far, we've been given a position equation, and we've been asked to find the velocity and acceleration when we when at a certain time. Now, however, we're going to be asked to find the position function. So these were my favorite calculus. Yeah, I enjoyed these as well. So back to the glue I go. Try not to use too much of the glue. I don't want to use up all the glue on purpose. All right. So, an object is thrown from the top of a 220-foot building with an initial velocity of 26 feet per second. Write the position equation for the movement described and what is the velocity at 1 second. So, we're going to need, is velocity the derivative? It is indeed. It is the first derivative of the position function. But here, I don't know what the position equation is. I need to write the position equation. So luckily, we can use what's called a general position function. And here, it is. So, S of t is equal to 1/2 times the gravitational constant times time squared plus v naught squared times t plus s naught. So here, my v naught is my initial velocity, and my s naught is my initial height. And because we're using feet per second, the gravitational constant would be about negative 32. So negative 32 times 1/2. Can you see it now? Hi, Caden. How's it going? Better? I'll move it up a little more. Is that better? Perfect. So here, because I'm using feet per second, my gravitational constant is about negative 32. So 1/2 times negative 32 gives me negative 16. My initial velocity is going to be whatever it's given, and my initial height is going to be the height of the building. So in order to write the position function, I'm going to move that up here so that we have it for reference. So S of t is what? So it's going to be negative, because we're dealing with feet per second, it's going to be negative 16 times t squared plus, or now here's a question. Is that 26 going to be positive or negative? What do you think? If this is being thrown from the top of a building, and I'm not throwing it up, depends on if they threw it up or down. Yeah, so if it's going to be, for this, right, we can say it's negative 26. Why? Because we don't know if it's being thrown up or down. We just know it's being thrown. So we assume that the object is being thrown either straight ahead or it's being thrown down. And then my distance is going to be, my initial height is going to be plus 220. Negative 16 comes from where? It comes from up here. Is this from an AP Physics 1? I'm not sure, but I know it's in calculus. And that is what we are doing. So, now that we have our position function, we need to find the velocity at t equals 1 second. So, here's what I'm going to do. I'm going to go ahead. Thank you, JF, for the follow. I'm going to go ahead and find my velocity. And remember, that velocity is the first derivative of position. Thank you, Justin, for the follow. Instead of algebra, you can also find x by interrogating. Good one. That's a good one. So, here, I need to find the derivative of this function. What's the derivative going to be? Just finished this unit in class. Awesome. How did it go? Can bro just get a job? Well, this is my job. My job is to show the world calculus. So, let's go ahead and, what would be the derivative of negative 16t squared minus 26t plus 220? You're welcome, user. I'm always happy to help. Thank you, Justin, for the follow if I haven't thanked you already. That's right, JF. It's going to be y, because 2 times negative 16 is negative 32. T to the 2 minus 1 is 1. And then negative 26, remember, a variable without an exponent is the same as that variable raised to the first. So what I'm going to do, take take 1, multiply it by negative 26. So that gives me negative 26. And then I have t to the 1 minus 1, which is 0. And remember, a variable to the 0 is equal to 1. So that is my derivative. And now, what do we want to know? We want to know what is the velocity at 1 second. So I'm going to plug in 1 into my velocity function. So I have negative 32 times 1 minus 26. If that's the case, then what must my velocity equal? How do you find average velocity? Sure, so usually to find average velocity, I would need an interval. Right, JF, it's going to be negative 58. Why? Because negative 32 times 1 is negative 32. Negative 32 minus 26 gives me negative 58. And what would my unit be? Is this calc-based? This is calculus. This is calculus, indeed. Feet per second. That's right, user. Feet per second. That's it. Again, any questions so far on this one? Or any of the other two that we've done so far? If it was thrown up, how would it change it? That's a good question. So let's assume that it was thrown up. So let's say instead of negative here, we make it a positive. So if a derivative instead of negative 26 will be positive 26, so negative 32 plus 26 would be negative 6 feet per second. So it would be moving slower in the negative direction. When do we set the equation equal to 0? So that's going to be when we want to know when it hits the ground. And actually, believe it or not, that's the next problem. Or actually not when it hits the ground. Sorry, let's try it again. So if I throw this pen up, there's going to be a point where it's not in motion and before coming back down. When we set this velocity equation equal to 0 is when we want to find out, okay, at what point t is it just in motion or not in motion? Is it at the top of its flight? Where did the 6 come from? Are you talking about what I was saying a few seconds ago? Negative 6 would have been the answer if 26 were positive. If this term were positive. Can you explain the Fermi-Dirac distribution next? I would have to look up what the Fermi-Dirac distribution is. Oh, are you talking about here? Sorry, Owen, I must have misunderstood you. I apologize. Yeah, so what I did was I just took the derivative of 3t squared. So I used power rule, which says take the exponent, move it out front, and multiply it by the coefficient, and then subtract 1 from the exponent. Explain Lebesgue integration, please. Have I actually ever done Lebesgue integration? I'm not sure. Either way, tonight I'm just going to deal with these types of problems. Rho didn't show the work for the derivative at all. Aren't you supposed to teach? Do you want me to show you the power rule? Yet I can. Yeah, I'm not doing limit definition tonight. I'm actually in the process of I'm in the process of downloading all my past lives. I did it in another live, but I'm not doing it tonight. Sorry, but that's a good question. So that is a really good question. Here's what happens to that 220. So refer to this rule. So when I have a number without a variable, that's called a constant. And if I have a function equaling a constant, then its derivative is going to be 0. Thank you, Angelica. Yeah, so that's where that 220 went. It just turned into 0. Shouldn't there be a plus c? I'm not integrating, so there wouldn't be a plus c. Right, Smokey, that's exactly right. Because it's constant. Yeah, no problem. No problem at all, David. Why is there a C for integration but not derivation? So the reason why is because when we integrate, when we take what's called the indefinite integral, we don't know. There's infinite many functions that a function could be the integral of. So instead of, but they all differ by constant. So it could be +0 or +2 or +7,000,000. So to write for all of those, we add a plus c. But because because this function only has one derivative, the plus c is unnecessary. So now, if there's no other questions, if the ball is thrown up, eventually it goes down. Is -6 feet per second the average of up and down? Nope. So -6. So -6 for this problem. If I threw it up at an initial velocity of 26 feet per second, then what would happen is this would be positive, which means that 26 would be positive. That 26 would be positive, which means this 26 would be positive. -32 times 1 is -32, plus 26 would be -6. So if we threw it up at a rate of 26 feet per second, then the velocity at 1 second would be -6. I'm just here to thank you, Zamella, for the follow. You're just here to learn. You came to the right place. Awesome. So now it's time to turn the page. So I have 3 more problems for us tonight. Oh, I see. Yeah, no problem, user. No problem at all. Now, while I'm attempting to glue the next problem, let's see if we can't do a quick mad tap to 9K. Thank you for sharing the live. All right, so we are almost at 9K. Let's go, everyone. You are all doing great. Thank you, Zamella, for the rose. Thank you for the 2 roses. Awesome, and we are at 9K. Perfect. So, now, let's talk about this. At t = 0, a rock is dropped from rest from the top of a building 256 feet high. When and with what velocity does it strike the ground? Okay, so here, first we need to find the position function. So remember this function. So we're dealing with feet. So the gravitational constant would be -32. So here I'm going to start with s of t is equal to -16 t squared plus, what's my initial velocity? If I dropped it from rest, what is its initial velocity? That's right, Solomon. That's right, Smoky Pool. It's 0. So my initial velocity is 0, so I can plug in 0 for v naught. 0 times t is 0, so I'm not going to include that. And what is the initial height? Solomon says 256, and that is the right answer. So it would be plus 256. Right, that's exactly right. It is 256. So now we are asked when and with what velocity does the rock strike the ground. So the first question I need to answer is when. So when so we're essentially asked, okay, when is the position function equal to 0? So I'm going to plug in 0 for s of t. So 0 is equal to negative 16t squared plus 256. Nope. No, I do not. I do not have to convert it to meters. Where do I get negative 16 from? Sure. So, because I'm dealing with feet, the gravitational constant is about negative 32.3, I believe. But we just round it down to negative 32. So, or should I say round up because it was opposite in negative world. Anyway, so negative 32 divided by 1 times 1/2 is negative 16. Right, it's from the formula. So now, what I'm going to do is I'm going to go ahead and solve for t. Actually, what would t equal? User says 4. Under what assumptions can we use this formula? So this is the formula that we are using for calculus. If this were in meters, then it would be negative 9.8. It would be the same function here. These two would be the same, but instead of negative 16, it would be negative 9.8. Almost, Ahmad. You would be missing. Not quite. Yeah, so this negative 16 is the gravitational pull. This negative 16 is from gravitational pull due to gravity. Did I just say gravitational pull due to gravity? Good job, Robert. So yeah, so I'm going to go ahead and subtract 256 from both sides. Right, there is a negative right here. Yeah, no problem. Yeah, no problem at all, Ahmed. So I have negative 256 is equal to negative 16 t squared. So now I'm going to divide both sides by negative 16. Okay, Solomon, I'll never mind. So here, we can say bye to those negatives. 256 divided by 16 is equal to 16. And negative 16 t squared divided by negative 16, we can say bye to those negative 16s. And I'm left with t squared. Thank you, Ahmed, for the follow. And now I'm going to take the square root of both sides. I have to ask you this question. Can time be negative? No, right. Time keeps on ticking into the future. So when I take the square root, I'm only worried about the positive square root. So t would equal 4. So that is part 1 done. And now we move on to part 2. So we figured out when it strikes the ground. Now we need to know with what velocity. I'm still confused on the gravity part. Okay, where are you talking about this original equation? Correct. But if we convert from meters to feet, it ends up being like negative 32.3. Right. Yes, we're doing freedom units in here. But yeah, no, if we did metric, you are right. It would be negative 9.8. Or if we, assuming we don't round to 10, negative 10. Indeed, I was hoping someone would get that reference. So yeah, now I need to figure out with what velocity. So now I need to take the derivative of the position function. What would the derivative be? 16 comes from where? That's right, Nick. It would be negative 32t. 16 comes from where? So I have all I'm answering your question with a question. Um so actually no, I won't answer it with a question. So when I do, because I'm dealing with feet per, so this is the gravitational constant. Well, technically that's technically incorrect. So here is the general position function for our formula. Because I'm dealing with feet per second, the gravitational constant ends up being about negative 32. So negative 32 times 1/2, that's where I get that negative 16 from. Thank you, David, for the follow. I needed this bad last week. Okay. Well, it'll be ready for the next time you see it. So now, so remember, negative 16t squared. So I'm going to take my 2, multiply to negative 16, so that's 32. T to the 2 minus 1, which is 1. And then remember, I don't see a variable here, so that's a constant, and the derivative of a constant is 0. So this is negative 32t plus 0. So now what I'm going to do, we found out the time at which the rock strikes the ground. So I'm going to find out when t equals 4, what the velocity of the rock is. 32 times 4. So what would the velocity be? Where do you get ne? How? All right. I don't. Right. That's right, Nick. I was gonna say I don't. I've actually lost count at this point how many times I've answered that question. But yeah, so what would the velocity be at time equals 4? Right. It would be negative 128. What's my unit? Feet per second. That's right, Mike. That is right. Thank you, Splash, for the follow. So, that is right. So, yeah. What questions do we have? From that formula, that's where I got the negative 16t squared from. Because when we deal with feet per second, the gravitational constant is about negative 32. So if I take negative 32 and multiply it by 1/2, that gives me that negative 16. I love this. I definitely need a refresher. I thank you, Zamela. I apologize if I've been pronouncing your name incorrectly. Um, I like to think I'm intelligent. I'm not always that intelligent, but thank you anyway. Tell them G is always 32. Okay, 10.4 or negative or 9.8. Yeah. So it really depends on if we're dealing with meters per second or feet per second. If we're dealing with meters per second, the then the gravitational constant is negative 9.8. Whereas if we're dealing with feet per second, the gravitational constant is negative 32. Hence why we would get negative 16 by multiplying it by a half. He's using feet per second for gravity. It's negative 9.81 meters per second. Right. And the only reason I'm using feet per second is because my units are given in feet. Agreed. Thank you, Kiana, for the follow. Yeah, no problem, Kevin. Yeah, I'm a calculus tutor. It's been ages since I've done physics. Thank you, Nick, for the follow. Although I will say my physics teacher tried to recruit me to be a physicist. Can you show the previous general equation? Sure, it's right here. I'm just working on gluing this problem. Because my glue stick ran out of glue, so I have to resort to not a glue stick. I'm actually taking calculus in college right now. That's cool. That's really cool. Yeah, I made a 72 on my first physics exam. I need help. Okay. I haven't done physics in ages. Actually, the last time I took a formal physics class was in my senior year of high school about 15 years ago. I have forgotten a lot about it. I took calc in 1984. Wow. That's really cool. I wasn't even a thought in 1984. Can you review physics and teach it, please? Sure. Give me a couple months and I'll see what I can learn. I just had my first Calc 3 exam and it was rough. Wow, oh boy. Yeah, no problem. Yeah, I can relearn physics. It's just going to take me a minute. Oh, absolutely. And I think that's going to help as well if I want to relearn physics. But there's algebra based physics and calculus based physics. I'm probably going to lean towards the calculus based physics if I do review physics. How about MCAT shortcuts? What's MCAT? Hold on, I need to do some research here now. I need to figure out what this is. I'm sure I've heard of it before. I know I've heard of it before, but I don't remember exactly. Is what is MCAT? MCAT is the test to go to med school. Okay, awesome. Thank you, teacher. It's a test for medical school entrance. It's chemistry and physics, but no. Ooh. That that sound. Hopefully the numbers are nice and clean. Thank you, Allie. All right. So a stone is thrown straight down from the top of a 80-foot tower. If the initial speed is 64 feet per second, how long does it take to hit the ground, and with what speed does it hit the ground? Okay, so remember what I said about the difference between speed and velocity? Remember that the difference between speed and velocity is that speed doesn't take into account direction. So speed can never be negative. So, first question, how long does it take to hit the ground? Luckily, we can still use this formula even though we have speed. So, my S of t is equal to negative 16 t squared. In this case, this is still velocity because it's thrown straight down. I would normally agree, except again, velocity takes into account direction, whereas speed does not. Um, so speed. I don't think speed can ever technically be negative. But let me verify that just to make sure. That I could be wrong, and I have been wrong in the past. So in this case, they do say speed is negative. So you're right. You are absolutely right, Parker. Oh wait, no. So many comments, but that's a good thing. I like comments. Comments are good. Right, Nick. So it would still be negative. In this case, t plus 80. But it's just a wording issue. Okay, how did you get negative 16? Isn't g 9.8? If this were in meters, yes, it would be 9.8. But since it's not, yeah, no problem. Yeah, so the reason I'm using feet is because my units are in terms of feet. If these were in terms of meters, then absolutely I would use the negative 9.8 t squared. Thank you, Itzy, for the follow. But that's why I use that constant. Thank you, Parker, for the follow. When dealing with this general equation, will it always be 16t? If the unit is feet, then yes. Unless you're given a different function. Like question, we had two questions earlier. In fact, let me show you them. Right. There we go. So like here, we had the position equation be given as this. So it really depends on, but if you're in Calculus 1 and you're asked to find the position equation for a problem that involves feet, then yes. Thank you, Diamond, for breakfast for the follow. Yeah, no problem. Okay, so now let's go ahead and figure out how long it takes for this stone to hit the ground. So I'm going to set this equal to 0. Someone was asking me earlier about factoring trinomials. Here is a good example. Would you take the derivative and set it equal to 0? No, because that would tell us when if we were to set the derivative equal to 0, it would tell us when it stopped moving. Even if I throw something even if something drops like that, it still has velocity to it. So here, I'm going to go ahead, add 16t to both sides. Okay, I personally wouldn't do that. Here's why. I can factor, yes. Wait a minute. Is that the greatest common factor, though? Or can I divide by something larger? Okay, I have -8. Can I divide something by something bigger than 8? Right. Thank you, Black Orchid. It would be -16. -16 if you really like fractions. Well, here's the thing. If I factor out a -16, I would get -16 t squared divided by -16 is t squared. -64 divided by -16, or -64t divided by -16 would be 4t. And then 80 divided by -16 would be -5. And if you do want to do it that way, by all means. So from here, I'm going to divide both sides by -16. So then I get 0 is equal to t squared plus 4t minus 5. Okay, so now, in order for me to factor, I need to find two numbers that multiply to -5 and add to 4. So what are two numbers that can multiply to -5 and add to 4? That's right, Kendrick. That's right, Kendrick. That's right, Joseph. That's right, Flashy. That's right, user. This would be x plus 5 and x minus 1. So now I can use the zero product property, which tells me that either x plus 5 equals 0 or x minus 1 equals 0. Oh, right. You're right. You are absolutely right. It is t. Sorry about that. Got to keep our variables consistent. You're right, Joseph. So now, if t plus 5 equals 0, then what must t equal? You're absolutely right, Nick. So I will get -5 here. Or t equals 1. But t can't be -5. Speed does have no direction, but also time can't be negative. So this is an extraneous solution, which means that time is equal to 1. What about the fact that the discriminant yields a negative number? Let's see. Are you talking about the quadratic formula? Because for here, what would that be? It would be -4 plus minus the square root of 4 squared minus 4 times -5 times 1 all over 2. 4 squared is 16. And then I have minus 4 times negative 5 times 1. 4 times negative 5 is negative 20. Negative 20 times 1 is negative 20. So this would be a minus negative 20 all over 2. But then you have that double negative. Exactly, Elias. So this would be negative 4 plus minus the root of 16 plus 20, which is 36, all over 2. So the discriminant would not be negative. Yes, it would be. Negative minus a negative number is the same as adding. So yes, that's right. And then 16 plus 20 gives me 36. Yep. Right, 2 real solutions. But one of them is extraneous because time keeps on ticking or slipping into the future, as Seal once said. So now we need to figure out the velocity at time equals 1. So then, now I need to take the derivative of my position function. What would my velocity function be? Someone asked me about the negative 16. That was you, Vicky. So here is the general position function that we are going to be looking at. So because I'm dealing with feet per second, the gravitational constant is about negative 32. So negative 32 times 1/2, that's where I get that negative 16 from. Steen says negative 32t minus 64. Elias says negative 32t minus 64 is the velocity function. You are both correct. So that would be negative 32t minus 64. And now, what I can do is I'm going to plug in 1 for t. So v of 1 is equal to negative 32 times 1 minus 64. Which means that my answer is what? Negative 96. Right, Steen. And what's my unit? Are the Navier-Stokes equations easy to get a basic grasp on? I'd have to take a look at what they are, because it's been a while since I've done the Navier-Stokes, if I've ever done them. I remember learning about a NASA satellite that completely failed its mission because of their units. Yep, that's how important it is. Yeah, so yeah, it's negative 96. What is Navier-Stokes? So oh, that's why I don't remember them. So there are a set of partial differential equations that describe the motion of fluid substances. Feet per second. That's right, Joseph. That is absolutely right. And that is my answer. Nope, not meters per second, because my unit is in feet. Answer makes sense because velocity increases as it comes down. Right, but velocity is also takes into account direction. So this isn't saying that it's decelerate, that's slowing down. It says it's increasing in the negative direction. Right, it's negative because it's going down. Thank you, Bad Ash Media, for the follow. Right. So remember that velocity is a vector quantity. That is that takes into account both direction and magnitude. How'd you get negative 32 for your acceleration? So the conversion it go right. We just had a little bit of a disconnection. Can everyone still hear me? Can everyone still see the live? Have a good night, user. Awesome. Perfect. Thank you, Nick. Yeah, for some reason my internet just cut out. Thank you, Elias, for the follow. Yeah, so I if anyone's been keeping count, how many times have I had that question tonight? It has to have been at least 7. Yes, I know. So, anyway, it is time for the final problem. So to unlock the final problem tonight, there are 17 of us in here. Let's see if we can't get to 11K likes. Explain the reason behind the general position formula, like why it's written the way it is. So position takes into account both where you start and if there's any motion behind you. So, as I said earlier, we take so this negative 16, because we're dealing with feet per second, that's our negative 32 is our gravitational constant, as Elias said a few moments ago. By multiplying by 1/2, I get this negative 16. If we're dealing with with meters per second, then the gravitational constant is approximately negative 9.8. And then the velocity here, that tells me how oh, we're already at 11K already? Cool. So anyway, this tells me, okay, how fast is the object going when we start, and where is the object when we start the time. All right. So now, did I say 11K or 15K? I don't remember. Thank you, Steen, for the follow. Use what we know, A equals dv/dt and V equals dx/dt. If you integrate that with respect to x, you get that. Exactly, yes. Go over pulleys, please. It is, like I said, it's been a while since I've done physics. I could go over pulleys. It would take me at least a couple months to relearn the physics that I've forgotten. Explain again about why you wouldn't take the derivative and set it equal to 0. So the reason the derivative isn't being set equal to 0 is because we don't care about when it's at its highest or lowest point. We're actually going to learn about these things. I think I have them planned either tomorrow or Monday, called critical points. That is when we're going to set the derivative equal to 0. Because we're going to care about we're going to care about where is its highest. If I throw an object up, its derivative is going to be 0 because there's going to be a single solitary moment at which the object is not in motion. It's just hanging out, and then it goes back down because what goes up must come back down. All right. A rocket was shot straight up from the ground. What must have it been its initial velocity if it returned to Earth in 20 seconds? Maybe, I'm not sure. Okay, so we know the following. We know that a rocket is straight up from the ground, so its initial position is 0. And we know that it returned to Earth in 20 seconds. So, what we can say about this is the following. So we know that using this formula, we can use this to help us figure out our velocity and our initial velocity. 320 feet per second squared per second is the answer. Let's see if you're right. So I'm going to have negative 6 s of t is equal to negative 16 t squared plus, we don't know its initial velocity, so I'm going to write it as v naught times t. And because its initial position is on the ground, this is going to be plus 0. So rather than plus 0, I'm not going to write anything there. And then from here, if it returned to Earth, we'll say it hit the ground at 20 seconds. So 0 is equal to negative 16 times 20 squared plus 20 times v naught. So I'll write that as 20 v naught. 20 squared gives me 400. 400 times negative 16, that's the same as negative 16 times 4 with 2 zeros. So this will be negative 6,400 plus 20 v naught. That would equal 0. Adding 6,400 to both sides. 6,400. I get 6,400 is equal to 20 times v naught, which Elias said that we should divide by 20, and he's absolutely right. So v naught is equal to 64 divided by 2 is 32. 2 zeros divided by 1 zero is 1 zero. So my initial velocity is 320. And what's my unit? Well, because we're using this, it's going to be feet per second. Thank you, Essentials, for the follow. Heading out, appreciate you doing. Yeah, no problem. Not a problem at all. We just actually did our last problem, Nick, so perfect timing. So yeah, so I'm going to go ahead and call it a night. But before I go, I'm going to go ahead. I want to go ahead and plug a couple things. So first, as I said earlier, I'm in the process of downloading all my lives. In fact, I think 4 of my lives from earlier just got uploaded just before it's live. So if you go here and you go to this channel, you'll be able to see all my past lives. So be sure to do these 5 things if and when you go there. Also, I am working on some things that I'm making. So I'm currently in the process of working on my calculus flashcards, my calculus rules. And again, I don't really want to call this a calculus rules. I'm going to call it more of tips and tricks. because I don't want to make it just like one of those things where you find that you can find on the internet a list of derivatives and integrals. I want to show you the what tools I've used to help me with calculus. And speaking of that, I'm also in the early stages of working on my calculus notebook. I should have an update here in the next few days on that. But as soon as all three of these things are done, they will be on my TikTok shop for you to get. Also, I am an online math tutor. And here is a list of everything that I tutor. I have a college calc test on Thursday. Good luck, go. Best of luck. So, I offer group tutoring and I also offer one-on-one tutoring. So for group tutoring, I offer group tutoring to groups of 3 to 10 students, all taking the same class at the same time. Now that doesn't have to do now you don't have to have the same teacher or even be at the same school. If you and 3 of your friends are all taking algebra 1 and you're all taking it at the same time, then you can do online group tutoring. And I also offer one-on-one tutoring as well. So if you're interested in either, please feel free to DM me here and we will schedule a free consultation. Lastly, there are a couple other people here on TikTok that I highly recommend you follow. First, I recommend you follow ACG Math Tutoring. She does a really good job of helping people with their ASVAB, their AccuPlacer, their GED, their TEAS test, and also also does really good at reviewing Algebra 1 and Algebra 2 and geometry concepts. She was actually the one who convinced me to join TikTok in the first place, so if it weren't for her, I wouldn't be here. And then, I also want you to follow Learning with Lynette. I believe she's live right now, so as soon as I'm done here, I'm going to go ahead and jump into her live. So, she does a really good job teaching people about the abacus. I'll be honest, when I first started here on TikTok, I didn't think I was going to learn as much as I did about the abacus, but she does a really good job. And yeah, go ahead and give her a follow. So with that, I'm going to go ahead and call it a night. Have a great rest of your evening, everyone. And I will see you all tomorrow or today if you're here on the East Coast like me at 11:30 p.m. Eastern. All right, have a great rest of your evening, everyone. Explain why it's negative 16 and not positive if it's shot straight up. Because we still have to, because even though an object goes up, it still is bound by gravity. Like if I jump up in the air, I'm I'm not I'm not immune to gravity. So that's why it's still negative 16 there. Good question though. Yeah, no problem, Joseph. Have a great rest of your night, everyone, and I will see you tomorrow. Bye, everyone.